and column, we'll set this equal to 0 for now. There isn't going to be any apparent change, it's still going to be in the same place. But one thing that we can do is use an option called column span. We can have a widget take up more than one column, and it's going to place this widget in between both of these columns, in between the combined width of both of them. So we'll add column span equals 2. So this widget is going to take up the next 2 available columns, including the one that it's currently in. And you can see that our submit button is now between these 2 columns that we have. One thing that you should know is that the column width is dependent on the width of the largest widget that is contained within that particular column. Let's say that we increase the width of our first name label. Well, our column is going to expand to actually fit that widget that we have. So for our first name label, let's set the width to maybe 20. And this is going to increase the width of column 0. And to even better demonstrate this, let's color each label a certain color, just for a visual. For our first name label, let's say this is red. And then for our last name label, let's set this to green. And then for email, maybe blue. Now, all of these are color coordinated, and you can see that the background color of our first name label is taking up the entire column space. Now, what if we changed the size of our email label to something even larger, like 30? So width equals 30. And now the column 0 has expanded to accommodate the size of our largest widget, which is our email, which has a width of 30. And before we finish this video, let's add a title to the submission form right on top of the first name label and the entry label. So let's call this title label equals label. We're adding this to the window. Let's set some text. Let's say enter your info. And let's pick font. Font equals, what am I feeling like today? Maybe just Arial. And then a size, maybe 25. We're going to use the Grid Geometry Manager. And we want this at the top, so we want row 0 at least. I want this to take up 2 columns. So we'll say column equals 0, and then set a column span. Column span equals 2. Now, a few things are going to overlap here. So we're going to move everything down by 1 row, besides our title label. So we want this first name label to be directly underneath our title label. So let's move everything down by 1 row. And our title is going to be directly on top of our first name label, as well as the first name entry box that we have. Alright, so that's the very basics of the Grid Geometry Manager. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Grid Geometry Manager in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well. And in this video I'm going to teach you guys how we can create a progress bar in Python, so sit back, relax, and enjoy the show. Okay, let's create a progress bar, but we'll need a few imports to begin. The progress bar widget is found within that TTK module, so we'll need a separate import from that. From tkenter.ttk import everything. And we'll import everything from time as well. Let's create a window. Window equals tk followed by window.main loop. We're going to add a progress bar and a button to this window. When we click on the button, it's going to fill our progress bar. Let's begin by creating a button to begin with. Let's call this button equals button. We're adding this to the window. Let's set some text. Text equals maybe download. And then a command. Maybe I'll call this start. Finish by adding this button to the window, and we'll just use pack to do that. Let's define what our start function does. def start. We'll fill this in later. I'm just going to print nothing just as a placeholder. And we should just have a button. Now let's add a progress bar before this button. And we'll call this progress bar just bar for short. Bar equals progress bar. We're adding this to the window. We can set an orientation. This can be horizontal or vertical. Later on in this video, I'll show you the differences between the two, but for now, let's set this to horizontal. And then I'm going to pack this bar.pack, and add some padding. Pad y equals 10. And let's see what we have. Okay, this is our progress bar at the top, and this is the button. When we click on this button, it's going to fill our progress bar. But I think I'm going to increase the length of this progress bar. Let's set this to maybe 300. I believe 100 is the default. Okay, that's not too bad of a size. Now let's define what our start function does. We can actually increase the value of our progress bar by typing in the name of this progress bar here. Value plus equals some amount, let's say 10. So what's going to happen right now is that every time we click on this button, it's going to fill our progress bar by 10 out of the total, which is 100. Let's pretend that we're waiting for a certain amount of tasks to complete. So let's define a few variables. Let's say we have a variable called tasks, and let's set this to 10 just to keep it simple. And x will represent the current task that we're on, and we'll say 0 to begin with. Let's create a while loop. While x is less than the amount of tasks that we have, we will increment the value of our bar by 10%. 10% for each task that we have, which is 10 for a total of 100%. And we'll want to increment the task that we're on as well, which is represented by x. So let's increment x by 1 after each iteration of this while loop. Now, when we run this and click download, this fills instantly. Let's add a delay just to simulate each task waiting to be completed. So let's add that here. Let's add a delay by using time.sleep, and let's set this to 1 second. We're going to wait 1 second and then complete a task. What ends up happening now is that nothing appears to be updating. Well, what gives, bro? You lied to me. Well, that's because the window is waiting to have this progress bar complete before it's actually going to display it being filled. So we would want to refresh this window after each iteration of the while loop. So at the end of this while loop, let's add one thing: window.update_idle tasks. After each iteration of this while loop, it's going to update the window that we have. So then when we download something, it's going to update our progress bar after each iteration of this while loop until it's completed. Right about now. Let's take this a step further by adding a label that displays the current percent of the progress bar that is complete. Let's add this label after the progress bar but before the button, sandwiched right between these two widgets. So let's add that here. We'll call this label %label equals label. We'll add this to the window, and we'll need a text variable. Text variable equals, let's call this %. So the reason that we use a text variable is so that we can update this label with some text after each iteration of our while loop. And we'll need to pack this. Okay, within the window, near the top, let's define %. % equals string var. This allows us to update % with some new text and set the % label with the new text that we have within the while loop. But before we update idle tasks, let's set what % is. %.set, and let's say x divided by tasks. And then we'll multiply this by 100%. I'm just going to put this within its own set of parentheses times 100, and then we'll convert all of this to a string so we can display this along with some text. There are a lot of parentheses here, so it might be difficult to keep track of all this. All right, and then we're just going to tack on %, and that's it. Let's try it. So we got 10%, 20, 30, 40, 50. I'll shut up now. One change that I'm going to make is that I'm going to cast all of this as an integer before we convert it to a string. because I do not like that decimal at the end of our percentage. So yeah, it says 10%, 20, so on and so forth. Let's add a label that displays the current task that we're on. So let's copy what we have for our percent label, and let's rename this as maybe task label. Task label, text variable will equal maybe text. And let's define what text is. So text is also a string var. And within our while loop, let's update the value of our text. Text.set will display x plus maybe a forward slash plus our tasks. And since we're displaying integers along with some strings, we need to convert these to strings, and we can use the str function to do that for us. So surround x and tasks with str to convert these to strings, and then we'll add just plus tasks completed. So the value of x will update after each iteration of this while loop. Let's try it. And after clicking download, this will display the percentage as well as the amount of tasks that have been completed, all the way until it reaches the end. Let's change this into a more practical example. We'll pretend that we're downloading a video game. So let's replace or rename tasks as maybe GB for gigabytes, and this game will be 100 gigabytes. We'll rename X as well. So let's refactor, rename, and change X to maybe download to represent the amount of gigabytes that are downloaded. And let's create a variable called speed. And let's set this to 1. All right, so while our download is less than the amount of gigabytes for this game, we'll sleep for maybe a portion of a second. 0.05 should be good. We'll increase the value of our bar by this amount, speed divided by gigabytes, and then multiply this by 100. For the download, we're going to increment this by whatever our speed is, and right now it's 1, so that's the same. We can keep percent the same. For our text, let's change tasks to gigabytes. And that's all the changes that we have to make. And now when we download something, we're kind of pretending that we're downloading a large file or a game. You can see that once it reaches 100, it says 100%, 100 out of 100 gigabytes completed. Now we can change this to a different value, let's say maybe 50, and the speed will be maybe 2. So this will adjust to accommodate whatever the new file size is as well as the speed. And before I forget, you can change the orientation to a vertical bar if you so choose. So we have this vertical download bar now, which could be good for something. All right, so that's the basics of progress bars in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of progress bars in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use the Canvas widget to draw some simple shapes. So sit back, relax, and enjoy the show. Welcome back, everyone. Well, in this video, we're going to be creating a canvas. A canvas is a widget that is used to draw simple graphs, plots, and images within a window. We're going to be creating some simple shapes in this video. Not anything too sophisticated. I might get more into the canvas widget in a separate video. And at the end of this lesson, we're going to practice by creating a Pokeball. So to begin, we'll need a window. Window equals tk, followed by window.main loop. To create a canvas, we can just simply call this canvas. Canvas equals canvas, and we're adding this canvas to our window, and then we need to follow this with canvas.pack or place. But I'm just going to use pack because it's simple. This is what our canvas looks like. It's a rectangular area which we can draw graphics on. We can also set the width and the height of this canvas. So when we create this canvas, we're going to set the options for a height and a width. So let's begin with the height. Height equals, let's say 500, and the width will be the same, 500. And now we have a square canvas that we can draw graphics on. Let's begin by creating some simple shapes. Maybe a line. I think a line is a shape. Maybe a one-dimensional one. I don't know. I don't geometry. So let's create a simple line. So we type in the name of the canvas, dot create, and there's a bunch of different shapes that we can create. Let's create a line. Now I'm just going to turn this into a comment for a moment. We need to set some coordinates for this line. This top left corner of our canvas is 0, 0, and the bottom right corner of this canvas is 500 by 500. Depends on what you set the dimensions of the canvas to. So when we create a line, we need a starting point and an ending point. So if we want this to start in the top left corner, we're going to pass in 0, 0. That is the starting position, and we can place the coordinates for the ending position. If we want this line to end in the bottom right corner, that would be where x is 500 and y is 500. And this is what this looks like. We just have a simple line going across the screen. But that's not all. We can also change the color of this line and the thickness. Let's begin by changing the color. So we can do that with fill. Fill equals, let's pick the color blue. And now we have a blue line going across the screen. But we can also change the width of this as well. So we can do that using the width option. And let's set this to 5. Now we get an extra thick line across the screen. Now let's make a red line. So I'm just going to copy this, canvas.createLine, and let's change some coordinates for this. Let's say we want this to start in the bottom left corner and go up to the top right. So the starting x position would be 0, y would actually be 500, x for the ending position would be 500, and y would be 0. And let's set this to red, and we'll keep the width the same. Okay, so here's our red line, and notice that this red line is overlapping the blue line. So when you create shapes on a canvas, if there's any that overlap, the one that you most recently created will appear on the top. One option available to you is that you can actually give these graphics a unique name. With our blue line, we could call this blue line. Blue line equals all of this, and then we can call our red line something different, like red line. This would be useful if you want to call or use a graphic by its name. If you want to move a graphic on the screen or have something appear, you can use this by its name. But we don't really need it for this lesson, so I'll just revert this back to what we had previously. I'm just letting you know that you can do that. All right, what do we have up next? Let's create a rectangle. So canvas.create rectangle. We can set some starting coordinates and ending coordinates. The starting coordinates are for the top left of the rectangle, and the ending coordinates are for the bottom right. So for the starting coordinates, let's say we're going to place this where x is 50, y is 50. For the ending coordinates, we want this where x is 250 and y is 250. I'm just making up numbers. Put it whatever you want, really. And this is what this looks like. But I think I'm going to comment out these lines for now. And here is our rectangle. Well, I guess it's also a square. We can actually give this a fill color as well. So we do that with the fill option. Fill equals purple, I guess. And now we have a purple rectangle. Next on our list is create polygon. We can create many sorts of shapes using create polygon, but it really depends on how many coordinates that we enter. Let's create a simple triangle, so we need at least 3 coordinates for this to work. So canvas.create polygon, and I have some coordinates picked out already. So let's place the first set of coordinates where x is 250, y is 0. For the second set, where x is 500 and y is 500. And the last set, the third set, we'll place this where x is 0 and y is 500. And what this looks like is that we have this black triangle that's taking up most of the canvas. We can also change the fill color as well. So we do that with the option fill. And we can set this to whatever color you want. Let's say yellow. And we now have a yellow triangle on our screen, and it kind of resembles the Triforce from the Legend of Zelda series, one of my personal favorites. Let's also add a border. This is actually done with outline. Outline equals, and then pick a color for the outline. Let's say black. And we have a black outline around this graphic. And you can also change the thickness of this too, with width. And let's set the width to 5. And now we have an extra thick line around our triangle. With these shapes, you can pass in a list of points too. So I'm going to get rid of all these, and we're going to pass in a list. So let's create a list called points. points equals all the points that we just entered in previously. And then instead of passing in all of these coordinates individually, I'm just going to pass in our list of points. And this will work exactly the same. Okay, let's create an arc now. So canvas.createArc. An arc is really just a curved line between 2 points. However, when we list some coordinates, we're not listing the coordinates of the starting position and ending position for this arc. It's more or less for the amount of space that we want to allocate to actually draw this arc. So let's say that we want this arc to take up the entire canvas. We can pass in the dimensions for this canvas. So the top left corner is 0, 0, and the height and the width are 500. So this is our arc. It resembles a pie slice. It's not starting in the top left corner and ending down here. That's the amount of space that we're giving this create arc function to actually draw an arc. It's really an entire circle, but only a portion of it is visible. Let's also set a fill color for this. So fill equals, what color did we not pick yet? Let's say green. And now we have a green pie slice. There's different styles you can do too. So we can change that with style equals, the default is pie slice. That's what we had previously. Let's change this to chord. This will draw a line between these 2 points, and this kind of resembles like a bow with arrows. And there is also just arc, where it's simply just a curved line. Let's change this back to pie slice, well, because I like pie. We can change the starting position of where this arc begins with the option start. So start equals 0 by default, so there's going to be no apparent change. Let's adjust this by 90 degrees. So this is in degrees. So this shifted, what is this direction? Counterclockwise by 90 degrees. So 180 would theoretically flip this. And now this is on the other side of what we had previously, and then 270. All right, we can also set an extent. So the default is normally 90 degrees, but let's change this to 180. And now we have a, what is that, hemisphere? Half a circle. All right, people, let's practice by creating a Pokeball. There's still one more function that we have to cover. It's called create oval, but we'll do that as we're making this. So let's begin by creating the top red hemisphere of this Pokeball. So that's canvas.createArc. And we're going to set the extent of this to 0, 0, 500, 500, so that this is going to take up the entire canvas. And then let's also set a fill color to red. So fill equals red. We need to change the extent of how far this extends. So we'll do that with the extent function. So extent equals 180, so that this is a half circle. And let's also change the thickness of this outline as well using the width option. So width equals 10 would be good. And we have a red hemisphere for the top of our Pokeball. Let's work on the bottom half. So that is a white hemisphere. So canvas.createArc, these are all the same. We'll change the fill to white. The extent will be the same, but we need a different starting position. So start equals 180. So this is going to begin at the 180 degree mark. So when you combine these both together, we get 2 different colored hemispheres that form a perfect circle. Now let's create an oval within the center of this Pokeball. So we're going to do that with canvas.createOval. We're going to set the amount of space that we want to give the circle to be drawn. So we'll place this where x is 190, where y is 190, where x2, or the second x position, is 310, and y2 is 310. Let's set the fill color next. So we do that with fill. Fill equals white. And lastly, let's just give this a thicker border. So that is width equals 10 to match the width for the 2 arcs that we have. And there you have it. We have a simple Pokeball. All right, well, that's the basics of the Canvas widget. If you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Canvas widget in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create key events in Python. So sit back, relax, and enjoy the show. Welcome back, everyone. In this video, we're going to be discussing key events. We can bind a key event and a function to a widget or a window so that when we press a certain key or do something, we can trigger a function to be called that will perform some sort of task for us. So we can actually do this by using the bind function. So widgets and windows have access to a bind function. So when our window or our widget is selected and then you press a certain key or do something, then it's going to call a certain function to perform a task for us. So there's two arguments within the bind function. This takes an event as well as a function name. Let's say that when we press the enter key, we want to call this function to do something. So for this event, what we type for that is a set of quotes, angle brackets, and the name of the button. So for example, if you want to press W to move forward, like you're playing a game, this would be W, A, S, D. There's also up, down, and then let's say we want to press enter to do something. That is actually a return. And then we will call this function. So let's create a function called do something. And let's define this at the top. DEF, do something. Now pay attention to this part. We need to set up one parameter for this do something function. This needs an event, so be sure to include that, and it's easy to forget. So what do we want to do after we press enter? Let's just print a message. You did a thing. And this should work now, so let's try it. So while this window has focusability, we can actually have this respond to events. So right now I'm pressing all sorts of keys. You can probably hear me right now going crazy on my keyboard. But now I'm going to hit enter, and it says you did a thing. And you can bind all sorts of keys to this window. Let's say that I want to press Q to quit. So we'll just replace this with lowercase q. So I'm typing all sorts of keys, but now I'm going to press Q, and it says you did a thing. Kind of like we're quitting the game. You can actually have this respond to all keys, well, almost all of them. So to do that, you just type in key with a capital K. So I can pretty much press on any key, then it's going to trigger or call our function. Kind of like that. So one thing that we could do, we can display the key event that was pressed. So I'm just going to add that here. Maybe I'll change this message. You pressed plus, and to display what key was pressed, that is event dot key sim. I believe that's for key symbol. So this will actually display what button you pressed. So WASD. Here's a unique idea for practice. Let's say that we want to add a label to our window, and we're going to change the text on the label to reflect whatever key that we press. So let's create a label. Label equals label. We're adding this to our window. And let's change the font as well to something massive, like Helvetica, and a size of 100. That should be good. Then we need to pack this label. So label.pack. Then within this function, let's turn this into a comment, and we're going to use label.config, and we're going to update our text. And the text is going to be whatever key that we press, so we can do that with event.keySim. So now this label is going to display whatever key that we press. So for example, WASD, backspace, escape, up, up, down, down, left, right, BA start. All right, so that's the basics of key events. If you could do me a favor and in the comments down below, just press F to pay respects. So if you want a copy of this code, I'll post this in the comments down below. But yeah, that's the basics of key events in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys all about mouse events in Python. So sit back, relax, and enjoy the show. Hey everyone, we're going to be discussing mouse events in Python. So before we begin, we'll need a window. So window equals tk followed by window.main loop. And in the last video, we learned that we can bind a widget or a window so that when a certain event occurs, we can call a function. So we're going to do the same thing for this video, but we have various mouse events that we can cover. So we're going to use the window.bind function. And this takes two arguments, an event as well as a function name. So let's define a function. Let's call it the do something function. So do something, and we'll need to define this. So at the top, def do something. And remember that we need to set up one parameter for this function. The parameter is an event. And then we'll just print something. Print you did a thing. Okay, so there are various mouse events for a left button click within quotes, and then within angle brackets, a left button click is button-1. So then if we were to click within this window, it's going to call our function, you did a thing. But if I were to right click, it doesn't do anything. So there are other mouse events too. So button 2 is that scroll wheel. Not if you scroll up or down, but if you press in on it. So right now I'm clicking left, I'm clicking right. Now I'm going to press in on the mouse wheel, and it says you did a thing. Button 3 is a right mouse click. So I'm clicking left, nothing, but I'm going to click right, and that seems to work. All right, so button 1, I'm just going to add a note. Left mouse click. Button 2 is the scroll wheel. That's if you pressed in on it. And then button 3 is a right mouse click. So did you guys know we can actually get the X and Y coordinates of where this event occurred? So to do that, we type in the name of the event, .x. However, since we're displaying this along with some text, we'll need to convert this to a string. So string event.x. Then I'll add the Y coordinates as well. Event.y. I think I'll just add a comma between these to separate them. And we'll change our text. So we'll say mouse coordinates. All right, let's try this again. So this is going to give us the coordinates of where we click. And right now I'm just left clicking. So the top left corner is 0, 0. Well, at least close to it. I'm not there exactly. All right, so here's a few other events that we can cover. I'm going to copy this. We have button release. If we were to release a button, it's going to trigger our event. So right now I'm holding in on the left mouse button, but I'm going to let go, then it triggers our event. If I were to right click and hold it, it doesn't do anything. But as soon as I let go, then our event is triggered. We also have enter. Not to be confused with the enter button. Just going to get rid of that. So that is enter. If we were to enter our binded window or widget. So if I were to enter, it's going to give the coordinates of where I entered this. There is also leave. So I'm going to say that enter the window. And leave is leave the window. So if I enter, nothing happens, but as soon as I leave, it gives the coordinates. And the last one is motion. As long as the cursor is in motion. So this one might be good for a game. So that is motion. Where the mouse moved. So it's consistently giving me the coordinates if I'm moving the mouse, but if I were stationary or stop moving, it stops. Alright, so that's the basics of mouse events in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of mouse events in Python. Hey, what's going on everybody? It's Bro here, hope you're doing well. And in this video, I'm going to teach you guys how we can drag and drop widgets in Python. So sit back, relax, and enjoy the show. All right, people, let's just dive into this. So we'll need a window, and then we're going to be adding widgets to the window. So window equals tk followed by window.main loop. Now you can drag and drop all sorts of widgets, but let's just stick with the label because creating a label is simple. So let's define a label. Label equals label. We're going to be adding this label to the window, and let's set a background color so we can actually see this label. Pick, I don't know, your favorite color. I'm going to pick red, and then I'm going to set a width and a height because normally if you have a label without any text, it's really small. So let's set a width of maybe 10 and then a height of 5. That should be good. And we want to place this label someplace within the window. So label dot place, and we can pass in some x coordinates as well as y coordinates. So x equals 0 and y equals 0. So that this is going to appear in the top left corner of our window. So this is what we have. This is our label, and we want to be able to drag and drop this label someplace within the window. What we're going to need to do is actually bind this label twice. But let's begin with just the first binding. So in order to bind a widget, you type in the name of the widget, followed by calling the bind function. So this bind function can take 2 arguments. It can take an event as well as a function name. So for the function name, let's call this drag underscore start. But you don't really need to name it the same that I do. And for the event that occurs, this is going to be a left button click with the mouse. So that event is within quotes and within angle brackets, button dash 1. So if we were to click someplace within the label using the left mouse button, it's going to call our drag start function. But we need to define this. So at the top of our program, let's define this function. Def drag start, and this takes 1 parameter. The parameter we have is our event. So what we're going to do is actually get the coordinates of where we click within this label, and we're going to assign these to a new variable or attribute of our label. So label dot, let's create an attribute called start x equals our event dot x. So this is where we click within the label and not necessarily the window. And let's repeat the process for y. So label dot start y equals event dot y. So we're going to have some coordinates of where we click within this label, and we can actually use that for our next function. So we're going to bind this label a second time. So I'm going to copy this line and paste it. The second binding, let's say, is drag underscore motion for the function name. And this event is going to occur if we were to hold down the left mouse button and then drag. So that is B1 dash motion. And then we need to define this function. So at the top, def drag underscore motion, and this takes our event as a parameter. So this part is going to be a little funky. We're going to get or create new x and y coordinates. So let's begin with x. X equals the name of our label or widget, label.winfo underscore x. This is a function, so add some parentheses. This will get the top left x coordinate of our label relative to the window that we're in, minus label x, well, label.startx, plus event.x. All right? So we're going to do the same thing for y. Well, we're going to replace x with y for the second line. All right, so this is the top left corner, the x coordinate of our widget relative to the window. This is the place where we click within the label itself. And this is where we begin dragging our widget to. It's a little difficult to explain, but if you combine all of these together, you'll get the new coordinates of where you want to drag this component, this widget to. So we need to replace this widget. So label.place x equals x and y equals y. So then when you combine all of these together, we have our widget, and we can drag it and drop it someplace else within the window. Now, wait a second. What if we have more than one widget? Well, with the way that our functions are written now, they wouldn't be compatible with more than one widget, just this label itself. So what if we were to create a second label? So I'm going to call this second label just label2. So I'm just going to rename them, and let's change the background color to maybe blue. And I'm just going to place this somewhere else within our window. So maybe where X is 100 and Y is 100. And we'll need to bind label2 as well. So make sure to bind label2. So we have label1 binded, it's just called label, and the same thing with label2. All right, let's see what happens. I'm going to attempt to drag label2, but label1 is moving. That's because with our functions, we stated we're getting the coordinates, and we're storing them within the attributes of label1 and not necessarily label2. So in order to make these functions compatible with all widgets, we can actually add one line of code. Widget equals event.widget. So this is going to get the widget of the event that we're dealing with, and we're going to temporarily rename this as widget. So now we're going to replace all instances of where we use label and replace it with widget. So be sure to do the same thing too with drag motion. And then we will need to add this line at the top of drag motion. So now these functions are now compatible with any widget that we create. And we should be able to drag and drop both widgets. All right, well, that's the basics of dragging and dropping widgets in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of dragging and dropping widgets in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can move an image on both a window and a canvas in Python. So sit back, relax, and enjoy the show. Alright, my fellow bros, I'm going to divide this video into two different sections. In the first section, we're going to move a widget within a window, and in the next section, we're going to move an image on a canvas. So let's begin by moving a widget within a window. So we'll need a window equals tk followed by window.main loop, and we'll also need to set some geometry for this window. Window.geometry, and let's make this 500 by 500. 500 x 500, and let's take a look. Okay, that should be a decent size. Let's add a label to this window. So I actually have a race car image that I want to use. If you would like an image, feel free to pause the video and download one. What I would like to do is create a photo image from this PNG file that I have. I'm just going to call this my image equals photo image file equals, since this is within my project folder, I can just list the file name. Otherwise, you might have to list the file path. And for me, this is called racecar.png. I want to add this image to my label. Not necessary, but it'll be helpful for this example. I'm going to call my label just a label. Label equals label. I'm adding this to the window, and I'm going to set the image to equal my image that I created. It's a photo image. If you do not have an image that you want to use, you can simply just change the background color. You could say BG, I don't know, red. Oh, then we need to place this, so be sure to do that. Label.place, and I'm going to place this in the top left corner. That is where x equals 0 and y equals 0. And then we should have a race car, or whatever image you used, and a red background. You can get rid of the background color if you prefer. That's just if you don't have an image to use, you can set the background color just for a visual to show you where the label currently is. Let's set some key bindings for this window, and let's add them maybe here before we create the label and our image. So let's bind the W key for up, S for down, A for left, and D for right. So we do that with window.bind, and we pass in an event as well as a function name. So we want to tie the W key to a function, and we'll call this move underscore up. And then we will need to define this. So outside of the window, let's define move underscore up. and this takes an event. So we'll place that as a parameter. And to move our label up, we're going to take label.place. And we're going to place this at some new coordinates. X equals the label's current position relative to the window that it's in. So that is label.w_info_x. All right, so then for y, it's similar. Y equals label.w_info_y. But we're going to subtract maybe 1. All right, so this is all we need. Although this is only going to move up. So I'm going to press W, and our label, our race car, or whatever image you used, is going to move slowly up. I'm going to increase this to 10, so the change is more drastic. So now our race car is drifting off into space. Let's bind a few other keys. S, A, and D. Sad. All right, so S will be down, move, _down. A for left, move, left. And D for right, move, right. We'll just copy what we have here and make a few changes. Let's begin with move down. The only thing we're going to change within here is, in place of subtracting 10 from the y coordinate, we're going to add 10. And with our race car, oh, I guess we have to define these, so let's do that real quick. So we have left, move left. We're going to subtract 10 from the x coordinate and keep y the same. And then the same thing for move right, move _right. And this time we are going to add 10 to x, and y will stay the same. Okay, now with our image, we can move up, down, right, and then left. And why stop there? We can bind these to our arrow keys. So up is just up with a capital U. Down is down. These are all capital, by the way. Left is left. And then right is right. And now I can use my arrow keys to move this image. Now, for this part of the video, I'm going to teach you guys how we can move an image on a canvas this time, and not just within a window. But we'll need a window to begin with. Window equals tk, followed by window.main loop. And we're going to create a canvas. Canvas equals canvas. We're adding this canvas to the window, and let's set a width and height. For the width, let's make this 500, and the height 500 as well. So this is an even square. And we'll need to pack or place this canvas. Canvas.pack should take care of that. And let's run this, and this is our canvas. At this step, we need to add an image to our canvas, and I have an image of a race car that I want to add. So I need to create a photo image from this file. So we can do that. Let's give this photo image a unique name. I'm just going to call this photo image to keep it simple. Photo image equals photo image. And I can list the file path or the file name. Since this image is within my project folder, I only have to list the file name, and my file is called racecar.png. This next step, we need to give our image a unique name, the image that's being added to the canvas. I'll call this my image equals, and we need to turn this photo image into an image added to the canvas. So we type in the name of the canvas, canvas.create_image. We first need to list the coordinates of where we want to place this photo image. So let's place this in the top left corner. That is where x is 0 and y is 0. And we need to set the image of the image that we're creating. So we can do that with saying image equals the name of our photo image. And let's see what we have so far. So this image is somewhat cut off in the top left corner. We can easily fix that by anchoring our image when we create it. So let's at the end add anchor equals northwest. So that should fix that problem. And we now have our image that we want to use. And to move our image, we can set some key bindings. So we type in the name of the window, dot bind, and we pass in 2 arguments, an event as well as a function name. Let's tie pressing the W key to moving up. So the first argument is going to be W, and the second is going to be a function name. So let's say move underscore up. And let's bind some other keys. W for up, S for down, A for left, and D for right. We'll need to define these now. So at the top, outside of the window, let's begin by defining move up. DEF, move up. This has an event as a parameter. And let's create the other definitions here. So I'm just going to rename these. So we have move up, move down, move left, and move right. Okay, now this next step. We can use the canvas's move function to move an image a certain amount of pixels on the x-axis and y-axis. So let's begin with move up. We type in the name of the canvas, dot, and use the move function. And this has 3 arguments, the image that we want to use, and this image is called my image, the one with the race car. The next argument is the amount of pixels we're moving this on the x-axis. With up, we can keep this the same, but on the y-axis, let's say we want to move this up 10 pixels, so that would be minus 10. And let's repeat the process for move down, move left, and move right. For move down, we're going to change y to 10. For move left, we'll keep y the same at 0, but we're going to subtract 10. And then move right, we are going to add 10 to our x's. And that should be it. So we can move up, down, right, left. And if you want to bind these to some arrow keys, all we have to do is just change the event so we can bind these to our WSAD keys, as well as up, down, left, and right. And this time I'm going to use my arrow keys. Up, down, right, and left. Alright, so that's a few of the basics of moving either widgets or images on a canvas or window. If you would like a copy of all this code for both examples, I'll post both of them in the comments down below. But yeah, that's the basics of moving widgets and images in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create some simple 2D animations in Python, so sit back, relax, and enjoy the show. Alright my fellow bros, in this video we're going to be animating an image on a canvas. We're only going to be moving this image up, down, left, and right. Feel free to download an image that you want to use. I'm just going to use this UFO emoji that I found. So we'll need 2 imports at the top from tkinter, import everything, that's what we usually have. We'll also need to import time as well. We'll need a window, window equals tk, followed by window.main loop. We'll need a canvas, I'm going to call the canvas canvas. Canvas equals canvas, we're adding the canvas to the window. I'm going to create something that's called a constant. We're going to create a constant for the width and the height of our canvas. So a constant is a variable or value that you don't plan on changing later at all, and a common naming convention for a constant is that the name of the constant is all uppercase. So I want the width and the height of this canvas to be constants. So for the width, this is going to be all uppercase. It's not necessary to make it all uppercase, but that's a common naming convention. For the width, I'm going to set this to 500, and the height set to 500 as well. And for the width of this canvas, I'm going to set the width to equal my constant, which is 500, and the height to my constant height. So the reason that I'm making constants is that we'll be reusing these a lot later in this program, so we might as well just declare them now and get it over with. So for the canvas, we're adding this to the window, we're setting the width to our constant of width, and the height to our constant of height, and we need to follow this by packing this. or place canvas.pack, pack to make it simple. So we should have a canvas on our window. Now, if you have an image that you want to use, we're going to animate it. I need to create a photo image from this file. It's a PNG file. It's called UFO, but yours is probably going to be named something different, so don't copy me exactly. I need to create a photo image from this. I'm going to call this photo_image, but name it whatever you want. This equals photo image, and I need to list the file path or the file name. Since this file is within my project folder, I only have to list the file name, and for me this is called ufo.png. Our next step is that we're going to take our photo image and add this photo image to the canvas, and we'll also give this image a unique name. I'm going to call this my image equals, we're going to use the canvas's create image function. So canvas.create image. There's a few arguments that we need to pass in. Where we want this image to appear, we need a set of coordinates. If we want this to appear in the top left corner, that is where x is 0 and y is 0. For the image, we're going to set this equal to our photo image, whatever you named this. And lastly, we should anchor this. I'm going to anchor this in the northwest corner to keep it simple. And we should have our image on our canvas in the top left corner. And here is my UFO that's being piloted by a green alien that's waving to me. Aliens are usually not that friendly unless they're abducting you. Our next step is to create a while loop. So we'll say while true. This will continue forever until we close out of the program. If you're looking at the code for a game, this might say instead while running. Running will be a Boolean variable that contains either true or false. So if this is true while the game is running, they're going to continue moving all of the characters on the screen. And then if somebody pauses the game or closes out of the game, then they'll flip this running variable to false. But to keep things simple, we'll just say while true, but that's something that you might see. What we'll want to do is get the coordinates of our image within the canvas, and this will return a list of coordinates. So let's create a list called coordinates. So coordinates equals canvas, and we can use the coords function to get the coordinates. I guess that's short for coordinates. And we're getting the coordinates of my image, so we'll pass this into this function. And then let's print this just to see what this returns. We'll print coordinates. Okay, now to update the window after each cycle of this while loop, we can use the update function of our window. So window.update will also have this thread sleep for, let's say, 0.01 seconds. So time.sleep 0.01. So here's a quick rundown of what we have going on so far within this while loop. We're going to first get the coordinates of where our image is located. We'll print the coordinates to the console window. This part isn't required, but it's going to help us for learning purposes. We'll update this window for any changes, and then our thread, which is in charge of running the program, is going to sleep for, I believe that's 1/100th of a second. So when we run this, our image is staying in place, and we know that our while loop is running because it's continuously printing the coordinates. The first number is the X position, the second number is the Y position. Now we're going to give our image a speed, or velocity. I like to call it velocity. And in fact, I'm going to give this image two velocities, one for how fast this image is moving on the X-axis, and another for how fast it's moving on the Y-axis. So I'm going to create two variables, one called X velocity, and I'm going to set this equal to 1, and Y velocity, and I'll set this to 1 as well. Okay, so what we need to do now is update the position of our image. So let's do that before we update our window. So I'm going to type in the name of the canvas and use the move function. This move function takes 3 arguments. What you want to move. I want to move my image, my UFO, and how far I want to move this image on each axis, each coordinate. So what I want to do is update the X velocity, the X position of my image. So I'm going to pass in my X velocity variable, and then Y will just keep the same for now. So we'll just say 0. So after each iteration of this while loop, my UFO is going to move 1 pixel to the right, and it's just going to go off into the void forever. And now if we replaced x velocity with 0, and for y we set this to our y velocity, this image is now going to travel down, and it will continue into the void forever. And then if we combined both of these together, we're going to move diagonally down and to the right. So what if we want this image to bounce off the walls? We're going to add some if statements. We're going to begin by just having this image bounce off the left and right walls. For now, let's set y velocity to 0 so that this image is only moving left and right. So before we move this image, we'll add an if statement. We're going to check to see if the x position of our image is either greater than the width of the canvas or if it's less than 0. So we take our coordinates and we're going to get the first element from this list. So that is 0. That is x, the x value. If coordinates at element 0 is greater than or equal to the width of this window, and this is a constant, so we can just place that here. If coordinates, well, x within our coordinates is greater than or equal to width, or coordinates at index 0 is less than 0, then we want to reverse the direction or flip the velocity. So we want to change our x velocity and make this a negative number. One easy way to do that is that we can take x velocity equals x velocity times -1. Or another way of writing this is just to say x velocity minus negative velocity. Now what ends up happening is that when this image reaches the right border, it's going to bounce back. However, it only bounces back after it reaches the top left corner of the image. We need to factor in the width of the image as well. So we're going to create 2 new variables, and let's do this right before the while loop. We'll want to determine what the height and the width are for our photo image that we have. So this is what we're going to write. Let's call these 2 values image underscore width and image underscore height. So we need to determine what the width and the height is for our photo image, and there is a function to do that. Type in the name of the photo image, dot, and there is a width function. And the same thing for height. Photo image dot height. And then we can reuse these. So I'm just going to add 1 line to this if statement. If the x position of our image is greater than or equal to the width of our window minus the width of our image. And I'm just going to put these within parentheses just to keep these more organized. And what ends up happening now is that when the right portion of our image hits the right wall, it's going to bounce off. And let's do the same thing for our y velocity. We're going to replace coordinates at index 0 with 1 and change that here as well. Replace width with height. And this is image underscore height. And we're going to change the y velocity this time. And when we move this image, let's also add the y velocity. And now our image is just going to bounce off the walls forever, but it's kind of predictable since we set x and y to equal 1. Now let's change the speeds to kind of spice things up. Let's say for the x velocity, this is 3, and y velocity, this is now 2. This is going to go in a completely different direction. So you can mess with the speeds however you want. So guys, how about we add a background image to this? Well, because we can. I'm going to reuse this image of space from my Java video on this same topic. I need to create a photo image from this, and I'm going to copy what we did for our normal image that we were moving and animating. So this is called space.png. Well, that's the name of my file. And I'm going to give this image a different name. Maybe I'll call this background underscore photo. And then I'm going to add this photo to the canvas. And I'm going to call this a different name. I'll just call this background. All right, so our window should have a background now, and then our image moves on top of the background. So make sure you add and create the background before you add any other images. Otherwise, the background might overlap your image. All right, so that's the basics of some simple animations in Python. If you want to copy all this code, I'll post all of this in the comments down below. But yeah, that's the basics of some animations in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can animate multiple objects in Python, so sit back, relax, and enjoy the show. Welcome back my fellow bros. In this video we're going to be animating multiple objects within a window. More specifically, we'll animate some circles, and each of these circles will have their own characteristics, speeds, and directions. So we'll need two imports to begin. From tkinter, import everything. We'll also be importing everything from the time module as well. We'll need a window equals tk, followed by window.main loop. I'm going to create two constants, one for the width and one for the height. Let's set the width equal to 500 and the height equal to 500 as well. We'll create a canvas and we'll be animating the circles that we're going to create on the canvas. So let's create a canvas. Canvas equals canvas. We're going to be adding the canvas to the window, and we'll set the width of our canvas equal to our constant width, which is 500, and our height equal to our constant of height, which is also 500, and we will add this canvas by using the pack function, canvas.pack. Here's our canvas, and we're going to be creating multiple circles. Let's pretend that they're all different sports balls, like a tennis ball, baseball, volleyball, bowling ball. They'll all be bouncing off of the borders, and once each of them encounters a border, they will change direction. Since we're going to be creating multiple objects, I think it's best if we do this with another class. So let's create another class. I'm going to go to File, New, Python file, and let's call this class Ball. And click Python file, and we need to define this class. Class Ball. And we also need a constructor for this ball class. We can create one with def, 2 underscores, init, 2 underscores again. And we can set up the parameters of what we want to receive if we were to create a ball object. So let's pretend that we're going to be creating a volleyball to begin with. So let's call this ball volley underscore ball equals ball. And we'll pass in some arguments. So let's set up the parameters first. What do we want to receive? One, we want to receive our canvas so that we can actually draw this oval. We can draw this ball. We should also have an X and Y position, a diameter, X velocity, Y velocity, and a color. All right, so when we create a ball, like a volleyball, we're going to pass in whatever the parameters require. So we need a canvas, X, Y, a diameter, an X velocity, Y velocity, and a color. So within the constructor for the ball, we're passing in our canvas. It's kind of like what we do with widgets. We're specifying what we're going to be adding this widget to. We're going to be adding this ball to our canvas. We also need X, Y, and a diameter. Let's make this simple by setting X and Y to both 0. For the diameter, let's set this to maybe 100. And we also need an X velocity and Y velocity. Let's set this both to 1. And a color, so let's pass in a string like white. Let's head back to our ball class and finish assigning all of these arguments that we're going to receive. The first step is that we'll say self.canvas equals the canvas that we receive when it's passed to us as an argument. Our next step is to draw this oval, draw this ball, and we'll say self.image equals canvas.create underscore oval. And with creating ovals, we can pass in X, Y, and with circles, the diameter is equal for both the width and the height. So we'll pass in our diameter twice. And lastly, a fill color. And we'll say this is equal to the color that we receive, which is white. We're going to set the X velocity and the Y velocity. This is related to the direction that it's initially going to head in. So self dot x velocity equals the x velocity that we receive. And we'll do the same thing for y velocity. Self dot y velocity equals y velocity. Now, since this is in another class, we need to import this class. From ball, import everything. And you can see that this red underline went away. So let's see what happens now. We have our volleyball, but it's not currently moving, so that's the next step. So let's create a function within the ball class called move that we can call upon. So we'll do this after the constructor, def move, and this will take self as an argument. The first thing that we should do is get the coordinates. So we'll say coordinates, and this is a list. Coordinates equals self dot canvas dot coords, and we'll pass in self dot image, and we will print these coordinates just to see what's here. All right, now we'll create a while loop within our main class. So let's add that near the end. And we'll just say while true. So while this is running, let's move our volleyball. So volleyball dot move. So this will call the move function of our volleyball. And then we will update the window. Window dot update so that this refreshes. And we will sleep for maybe 1/100th of a second. Time dot sleep 0.01, but you can put whatever you want here. So this is going to, at first, just print the coordinates of this ball. So it's not currently moving, and this time with our list, we have 4 coordinates. 0, 0, that's the top left corner, and 100, 100, that's the bottom right corner. So this time we have 4 coordinates that we have to deal with, the top left corner as well as the bottom right corner. Our next step is that we should move this image. Self.canvas.move. What object are we going to move? We're going to move self.image. And in what directions? Self.x velocity as well as self.y velocity. Now our ball is going to move across the window, and right now it's displaying all of the coordinates. We don't have any bounds set up, so it's just going to continue into the void forever. So we should set up some if statements to check to see if one of the borders touches one of the walls of the window. If so, it's going to change direction. So let's check to see if the left or right side of our ball touches one of the left or right borders. So let's write an if statement. If, and then let's take a look at these coordinates. If coordinates at index 2, that is this one, 0, 1, 2. So this is the bottom right corner with these 2 sets of coordinates. If coordinates at index 2 is greater than or equal to, and I'm going to put these within parentheses, self.canvas, and we need to get the width of the canvas. One way which we can do that is to use the winfo underscore width function. So this is going to get the width of the canvas. And then let's add one more thing. Or coordinates at index 0 is less than 0. So if this ball touches the left or right border, we want to change direction. So we can flip the x velocity. Self.x velocity equals negative self x velocity. And let's do the same thing for the top and bottom borders. So let's copy what we have. And we'll replace coordinates at index 2 with 3. And we'll also replace winfo underscore width with height. And coordinates at index 1. Change self.x velocity with y velocity. Same thing here as well. All right, and that should be everything. Let's try it. So let's see if this ball actually bounces off the borders, which it does. Pretty cool. So that's everything we need to do within our ball class. Now, if we need to create multiple balls, we can just construct them. So let's say this time we would like a tennis ball. I'm going to name this volleyball as tennis ball. And let's make the diameter smaller, like 5. But we'll make this a lot faster, like for the velocity, let's say 4 and 3. And the color, let's make this yellow. And we also need to call the move function of this tennis ball. So within the while loop, tennis ball dot move. And then we should also have a tennis ball moving across the screen in a different direction. Now, technically, we don't need to print the coordinates, but I tend to do that just for teaching purposes to better demonstrate all of this. Now, our ball class is acting as a blueprint for how balls should be created and the behavior that they exhibit. And if we need to create a ball, we can just come up with a name for the ball and call the ball constructor to take care of that for us, kind of like what we've been doing with widgets. So all we need to do to create another ball is come up with a unique name for the ball and instantiate it using our ball class that we created. So this time, let's create a basketball. I'll rename this as basketball, and we'll pass in different arguments based on how we want to customize this unique ball. So for the diameter, let's say this is now 125, and the x and y velocity, let's set this to something very fast, like 8 and 7. And with the color, let's change this to orange. And make sure you also call the move function. So basketball.move. And we should have a basketball moving across the screen. All right, everybody, so that's the basics of animating multiple objects in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to animate multiple objects in Python. Hey, what's going on, everybody? It's Bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a clock program in Python. So sit back, relax, and enjoy the show. All right, my fellow bros. In this video, we're going to be creating a clock GUI program. So we'll need a few imports from tkinter, import everything, and from time, import everything as well. We'll need a window equals tk followed by window.main loop. And in this program, we're going to be creating 3 separate labels, one for the time, another for the day of the week, and another for the date. So let's begin with just displaying the time, and we'll work on the day of the week and the date later. So let's create a label for the time called time label equals label. We're adding this to the window, and let's set the font because we can. I'm going to choose maybe Arial, and then a size of 50 so that this is somewhat large. I'm going to change the foreground color, that is the font color, and I will pick a hex value of green. So that is 00FF00, but feel free to pick whatever color you want. And I'm also going to set the background color, and you can pick a hex value or a color name. I'm just going to say black. And then I am going to pack this label, time label dot pack. Now we're going to call a function, and we'll call this update, and we'll define what this does. After every second has passed, we will use a recursive function to keep on updating the time every 1 second or so. So let's define what this function does. def update. There is a function within the time module called strftime, which we can use to return the current time and format it however we want. So we're going to actually place this within a string variable, and we'll call this time string. And this function is strftime. I'm actually going to go to Python's website just to give you an example of how this works. Here we are on Python's website, and this is the strftime function. And this converts a tuple representing a time as returned by GM time or local time to a string as specified by the format arguments. So when we call this function, we can pass in directives as arguments based on what we want to display. If we want to display the current time, there is a few directives that we can pass in. So let's say that we want a 12-hour clock as represented by a decimal number between 1 and 12. Well, we would pass in %i as an argument. If we want the minutes, that would be right here, %m. And if we want the seconds, that is %s. So we're going to pass in these directives as if they are arguments. So within this function, we'll pass in those format specifiers or directives. So I want %i followed by %m and %s. All right. But these also have to be within quotes, so don't forget that because I just did. Okay, this will display the current time. Oh, then we also have to update our time label. So time label dot config text equals our time string, because remember that this returns a string of text. Text equals time string. So this will display the current time. And right now it is 6 in the morning or so. However, we just get one long jumbled number. So it would be a good idea if we separated some of these numbers. So within our strf time function, I'm just going to add some colons to separate these values. And this will display the current time. It is currently 6:46 in the morning. Let's add AM or PM to the end of this. So the directive for that is %p. 6:46 AM. Now, how do we update this label every 1 second to reflect the current time? Well, that's a good question, and I'm glad you asked it. So we're going to use the time labels after function. We pass in a delay and then a function that we want to call after that delay. So let's say we want to call this function update every 1000 milliseconds or 1 second. So we'll pass in the delay as an argument, 1000 milliseconds, and the function that we want to call. And we're going to perform what is known as a recursive function. We're going to call a function within itself. So after 1000 seconds, we're going to call update again, and it's going to repeat the process. It's going to return the time and format that time and update our label with the new time. So what ends up happening now is that our clock is going to update every 1000 milliseconds. Now let's add a few other labels. Let's say the day of the week. I'm going to copy what we have here, and let's rename this as day label. But I probably don't want this to be the same size. For the font, let's say ink free because I like that font. And a size of maybe 25, and I'll get rid of the coloring. It's the same process as before, really. So let's replace time string with day string. The directive for strf time to display the day of the week is %a. And we're going to replace time label with day label. Text equals day string. And this will display the day of the week. And it is currently Wednesday. And if we want to display the current date, we can create a label and we'll call this date label. And I'll make the font slightly bigger, maybe 30. We'll copy what we have for our day string and rename this as date string. So we have a few options for the date. I want to display the name of the month, the day, and then the year. So that would be %, capital B, %, lowercase d. I'm going to add a comma to separate the day and the year, and %, capital Y. And then I want to set the text of my date label to my date string so that this will now display the current date. There's just one quick change that I think we should make. Right now we have 3 different labels, a time label, a day label, and a date label. And right now we're using the after function of the time label. So since we have all of these different labels, I think we should replace time label with our window, because our window has an after function as well, so that after 1000 milliseconds has passed, we can update the time, the day of the week, and the date. All right, so that's the basics of creating a simple clock program in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating a clock in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can send an email using Python, so sit back, relax, and enjoy the show. Oh, a quick note for you all, you're going to need a Gmail account to sign into as well as your username and password, so once you have those set, you're ready to begin. Alright, let's begin by importing the Simple Mail Transfer Protocol library. We'll need a couple of variables to hold strings. Let's say we have a sender, a receiver, a password, a subject for your email, as well as a body for the email. Okay, sender is going to be you sending the email, so enter your email in here. I'm just going to make up one, you@gmail.com. Actually, sender would be better, I would say. Let me change that. Sender@gmail.com. Let's say we have a receiver. This is who you're going to send the email to. Receiver@gmail.com. Don't actually enter in these emails. Use your own or the person that you intend to send the email to for your test, because these will probably not work, I'm assuming. Then enter the password for your Gmail account. So let's say password123. And a subject. Let's say Python email test. And a body. What do you want to say within your email? I wrote an email. Okay, so that should be good. So remember that you're going to want to change these to your actual Gmail account, and you'll want to send it to a valid email address too. And make sure that you use your password for your Gmail account. Okay, now we're going to create a header for our email, and the syntax on this is a little strange. We're going to say message, F, and then triple quotes. So what this triple quotes is that a triple quote string can span multiple lines of text. So the first thing we'll enter is from within our header, from, and then since we're using an F string, we can insert a variable at a given location when we insert a pair of these curly braces. So from will be sender, the next line, to, colon, receiver, then the next line, subject, colon, subject. This will be the title of the email. Then I'm going to add a new line and then insert the body. And if you want, you can give yourself a name when you send this email. Let's say maybe Snoop Dogg. And if there's somebody you want to send the email to and give them a name, you can say like Nicolas Cage. But these aren't necessary. Okay, so we have our header completed. Let me just add a note that this is our header. Okay, we're going to create a server object. Server equals smtp lib dot smtp. There are two arguments. The first is smtp.gmail.com. The other argument is the port number, and that is going to be 587. That is the default mail submission port, 587. Now we're going to take our server object and start TLS, Transport Layer Security. Okay, now we need to log in. So server.login, we will pass in our sender email, that's us, as well as our password. And let's print logged in. We'll eventually place all of this within a try and accept block later. All right, and then to send an email, type server.send mail, and we pass in ourself, sender, receiver, and our message. Sender, comma, receiver, comma, message. And let's print a confirmation. Print email has been sent. Now, if you were to run this program, you may encounter this error, SMTP authentication error. That either means your username password combination was not correct, or you need to turn on the less secure app access on your Gmail account, which you can find here. However, I would recommend turning that back off when you're done with this program just because your account will be less secure and I'm not liable if you get hacked. Hey, you know what? Let's place this code within a try block. We will try all of this code, and then if we encounter this exception, we can catch and handle it properly. So we will try these 4 lines of code, and we will handle our exception of smtlib.smtp authentication error. That means we could not sign in. So let's print unable to sign in. So I'm going to run this one more time, and instead of getting that ugly error, we should get a simple message that says unable to sign in. Once you have the proper username password combination for your Gmail account, and if you need to, set less secure app access to on, but make sure that you turn it back off when you're done with this. You should be able to send an email. Let's try it. Logged in, email has been sent. Here is a snapshot of the email that I received. I blurred out my actual email because I don't want it public because some of you guys are weird. So we have our sender, our receiver, and I gave myself a nickname of Snoop Dogg. That's why it says Snoop to Nicholas, the receiver. But you don't actually need a name for these. As long as you have the sender and receiver fields filled in, you should be good. We have our subject, Python email test, as well as our body. I wrote an email. Well, everybody, that's how to write and send a simple email using Python. If you would like a copy of this code, I will post this to the comment section down below. But yeah, that's how to send a simple email using Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can run a Python file using command prompt. So sit back, relax, and enjoy the show. Hey y'all, in today's video I'm going to show you all how we can run a Python file with command prompt. So first we'll need a script to work with. Let's just make a very simple program. Let's say print hello world, and then maybe we will ask for some user input. Name equals input. What's your name? And then at the end, we will print the word hello plus the user's name. Okay, so let's save this to a place that we'll remember, perhaps my desktop. Now to save this file to a separate location, go to File, Save As. You can pick a name for this Python file, then to Directory, click these 3 dots, and pick a location you want to save this to. To make this easy, I'm going to save this Python file to my desktop and then click OK. So the name of this Python file of mine is hello_world.py, then click OK. Now our second step is to open command prompt. To open command prompt, just search for cmd. If you're using Mac, I believe it's terminal. Step number 3 is that we need to navigate to the directory that contains our Python file. I saved this Python file to my desktop, so if you right-click on your file and go to location, you can just copy this address. Now within command prompt, type cd to change directory, space, and then paste that directory that contains your Python file. Hit enter. And for the last step, we need to invoke the Python interpreter by typing python space and then the name of the script. And the name of my script is hello_world.py. Hit enter to run the script. Hello world, what is your name? Bro. Hello, bro. So that is how to run a Python file with command prompt. I will post all of these notes to the comment section down below. And well, yeah, that's how to run a Python file with command prompt. Hey, it's your bro, hope you're all doing well, and in this video I'm going to show you all how we can use pip for Python to download packages and modules. So sit back, relax, and enjoy the show. Alright people, pip for Python. Pip is a package manager for packages and modules from the Python package index. If you're using Python version 3.4 or above, pip should already be installed. If you're using a Python version below 3.4, one option is that you can always update your version of Python. Just click download, open when done, go to customize installation, make sure that pip is checked, go to next, and add Python to environment variables, then install. Now to use pip, open up command prompt and type pip for a help menu. All sorts of different general options and commands will appear. If you need to check your version of pip, type this command, and here's a cheat sheet that I wrote. So to check the current version of pip, type pip -- version, enter. And currently, the version that I'm using is 21. If you need to upgrade pip, use this command. Pip install -- upgrade pip. Mine should be the latest version. Yeah, requirement already satisfied. And if you need a list of installed packages, type pip list. So here's all of the packages that I currently have installed. Some of these you might recognize, like NumPy, Pygame, PyInstaller. Those are just a few. To check to see if any of your packages are outdated, type pip list -- outdated. And this might take a second. Here are 4 packages that are outdated on my computer: Babel, Pygame, PyTZ, and Setup Tools. If you need to upgrade one of your packages, type pip install the name of the package. Let's say that I would like to update Pygame, then -- upgrade. I just realized that in my notes I'm missing update a package, so I just added that here. Now you can see that Pygame has successfully updated, and let's just check to see if it has by using pip list outdated. Pip list -- outdated. And Pygame is no longer in here, so it is up to date. And if you would like to install a package, type pip install and the name of the package you would like to download. Let's say I would like to download pandas. Pip install the name of the package, in this case, pandas.
2 very boring minutes later.
And it's done. So I should now have pandas installed, and let me check. Pip list. And here it is. I have successfully downloaded the package of pandas. So those are a few commands for pip, and if you're interested in downloading more packages, head to Python's package index. On second thought, I should probably show you all where that is. Python's package index is located at pypi.org, and you can do a search for all sorts of different projects and packages. So everybody, that is pip for Python. I will post my notes in the comment section down below. And well, yeah, that's how to use pip for Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can convert a Python file to an executable. So sit back, relax, and enjoy the show. Here's a quick disclaimer before we begin. Windows Defender and other antivirus programs may prevent your executable from running, but if you head to the settings section of your antivirus, you can disable that so that your Python file can run. Also, please be sure that pip and PyInstaller are both installed and up to date. I have a separate video on that if you're interested. Now, the program that I'm going to be converting to an executable has a GUI portion to it. I created a clock program in a previous video, so I'm going to turn this clock program into an executable. Now, I recommend creating a new folder on your desktop just because this process is normally somewhat messy, so we'll create a folder to contain it all. Now copy any relevant Python files and or images and paste them to within this folder. If you have an image that you would like to set as an icon for your executable, I recommend moving that to the same folder as well. Our next step is to open command prompt, and we need to change the directory of command prompt so that it's pointing to that folder that contains our Python file. So on your Python file, right click on it, go to properties and copy this location. And in command prompt, to change directory, type cd space and then paste that location. Now here's the cheat code to convert a Python file to an executable. Make sure that PyInstaller and pip are installed and both up to date. So type PyInstaller -F to make all of this one file. If you need the terminal window in your program, then omit this next part. Since I'm running a GUI application, I do not need that terminal window. So to remove that window, type -W. If you have an icon that you want to set, type -I and the name of your icon. However, it should be an ICO file. So if you have some other image that you would like to convert to an ICO file, here's how. If you need to convert an image to an ICO file, you can just Google convert to ICO, but one website that I commonly use is ICOconvert.com. Just pick a file to upload, so choose file. I'm going to convert this PNG file of an alarm clock, upload it. There's a bunch of different settings you can use. Convert ICO, and then download my icon. And once your ICO file is downloaded, I will drag and drop it to my folder, and I will rename this. Let's rename this as icon.ico. And here's that cheat code one more time. PyInstaller -F -W if you do not need the terminal window, -I if you would like to add an icon, the name of your icon, it should be an ICO file, followed by the name of the Python file, and mine is named clock.py, then hit enter. Alright, looks like building our executable has completed successfully, so open that folder back up. Your executable is located within this dist folder. I would recommend just dragging and dropping it to your desktop, and we can get rid of this old folder. But close out a command prompt. And by clicking on this executable will now run my Python program. Well everyone, that is how to convert a Python file to an exe file. I will post my notes to the comment section down below, and well, yeah, that's how to convert a Python file to an executable. What's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can create a basic calculator using Python, so sit back, relax, and enjoy the show. Let's create a calculator. After importing tkinter, we'll need to define 3 separate functions. Our first function will be named button press, and there is one parameter which we will call num. We're not going to fill this in quite yet, we'll get back to it later. We'll use pass as a placeholder. We'll also need an equals function to calculate our expression, and a function to clear our calculator. Okay, that's it for our 3 functions. Let's create a window. Window equals tk, and at the end of our program, we'll write window.mainLoop. Let's set a title. Window.title. Calculator. Program's good, but make sure you spell title right. And let's set a geometry of 500 by 500 should be decent. Now we're going to create a string named equation text equals a set of quotes. This will effectively be empty for the time being, and we'll need to create a string var, and I will call this equation label equals string var. Let's create a label equals label. We're adding our label to our window. I will set our text variable equal to our equation label. You can pick a font if you wish. I'll set the background color equal to white. A width of 24. And a height of 2. And we need to finish this by using label.pack. And we should have a blank label within our calculator. This will display our numbers that we're entering in, or our expression. Okay, this is the tedious part. We have to create all of the buttons, and I think we should place these all within a frame. Frame equals frame. We're adding our frame to our window. Frame.pack. Now let's create button 1. We'll do some copying and pasting later, so it's not as tedious. So button 1 equals button. We're adding our button to our frame. I'll set the text equal to 1, the height equal to 4, and the width equal to 9. And a font size of 35. Okay, we'll need a command. Command equals, I'll write a lambda function here. Lambda, we will call button press. Actually, I think I'm going to put this on the next line, just so it's easier to read. Button press, and we will pass in the number 1. And we need to add our button to our frame. Button 1 dot grid, and I'm going to set a row equal to 0 and a column equal to 0. And let's just test it. Okay, let's add the other buttons. I'm going to copy and paste everything that we have for button 1 and change button 1 to button 2. Set the text equal to 2. pass in 2 to button press. And for the row and column, I'm going to set the column equal to 1, but keep row the same. Okay, button 3. It's going to be the same process, really. So text equals 3, button press 3, row 0, column 2. And button 4. Text equals 4, button press 4, column. Actually, let's set this to row 1, column 0. And I need to change that too. Okay, let's just double check this. Okay, button 5. So button 5, text equals 5, button press 5, and let's set column equal to 1. Okay, number 6. I told you all this is going to be tedious. Okay, so row 1, column 2. Button 7. Okay, so row 2, column 2. Actually, let's change that to column 0. Much better. Okay, button 8. 8, 8, 8, 8. Row 2, column 1. Number 9. Row 2, column 2. And lastly, 0. So button 0, text equals 0, button press, pass in 0, and this will be row 3, column 0. Okay, not too bad. Now let's fill in some of the symbols. So we need plus. I'm just going to rename this as plus. The text will equal the plus sign, put that within quotes. And button press will be plus. Oh, and we should probably put this in a row and column. So let's say row 0, column 3. So it should be on the right-hand side here. Okay, we need minus. Let's change plus to minus. And place this at row 1, column 3. We need multiply. That is an asterisk. Row 2, column 3. And divide. That is a forward slash. Row 3, column 3. I promise we're near the end of creating these buttons. We'll need an equal sign. Let's say equal, equal. Text is the equal sign, and our command is going to be equals the function. And this will be row 3, column 2. Okay, we need a decimal. change the text to a decimal. Row 3, column 1. Okay, and lastly, we just need a clear button. Let's put this at the bottom. So clear, clear. Let's set the text equal to the word clear. And the command will be our clear function. And I think I'm going to pack this at the end. But let's change frame to window. Okay, let's check out all these buttons. Okay, not too bad. I think I'm going to change the width on our clear button so it's a little bit wider. Let's change the width to 12. That's a little bit better. Okay, let's fill in some of these functions. Let's start with button press. We're going to state global equation text. Then our equation text is equal to equation text plus we're converting whatever number or symbol that we receive to a string. And our equation label, which is a string var, will be set to our equation text. And let's test this. So we can type in any combination of numbers or symbols. Okay, let's work on our equals function next. So let's say global equation text total equals eval. Now eval will parse the expression that we pass in. Equation text and our equation label will be set to whatever our total is. And if we want to reuse our total, let's set our equation text equal to total. 2 plus 2 equals 4. Minus 3 equals 1, times 5 equals 5, divided by 2 equals 2.5. Now, what if we divide by 0? Well, we'll run into that ugly zero division error, so let's write our code within a try and except block. So I'm going to indent some of this, and let's write try all of this code, and we will catch a zero division error exception. So except zero division error, and I will set our equation label set, let's say, arithmetic error equation text equals a set of quotes. Okay, so we should be able to catch this exception now. 5 divided by 0 equals arithmetic error. Now, what if we have a syntax error? Like we type in just a bunch of symbols and hit equals. We'll probably want to catch the syntax error as well. So let's write an additional except block before zero division error. Or after, I guess it doesn't matter. Except syntax error. And let's change arithmetic to syntax, and we can keep equation text the same. So now our program won't crash if we type in a bunch of symbols. Syntax error. Now let's work on the clear button. So that is within the clear function. So we will set global equation text equation label dot set to a set of quotes to effectively clear it, and our equation text equal to a set of quotes as well. And that should be it for this program. Let's run this one last time. Let's say 3.14 times 2.1 equals 6.594 divided by 2.1 equals 3.14 minus 1. I'm just making up numbers here. Plus 10 equals 12.14. And let's clear this and start again. 1 plus 2 plus 3 plus 4 equals 10. I think that's good enough. All right, everybody, so that's how to create a basic calculator in Python. I will post all of my code in the comments section down below if you would like a copy for yourself. But yeah, that's how to create a basic calculator using Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well, and in this video I'm going to explain how we can build a basic text editor program in Python. So sit back, relax, and enjoy the show. Okay, people, let's create a text editor. Here's all the different imports that you'll need, and we'll begin by defining all of the different functions that we'll need. So let's say we have a change color function to change the color of our font, and for all of these functions I'm going to write pass as a placeholder. So we have change font, and this function will accept a varying amount of arguments, so we'll use that args keyword. We will need to open a file. New file, open file, save file, cut, copy, paste. Yeah, there's a lot of functions here. About. This is for an about section. And lastly, quit. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 functions. Let's create the main window that we're going to work with. Window equals tk. And at the very end, window.main loop. Okay, so let's create a title for this window. Window, title, notepad, program, I guess. Or maybe text editor program would be more appropriate. Text editor program. Okay, and we will need a file to work with, and I'll declare that now. File equals none. We'll need a window width and height. Window width equals 500 is good. And a height. Okay, so let's attempt to center this window, because right now it just appears to the side. So our next step is to get the screen width. Equals window dot w info screen width. And I'll copy this for screen height. Okay, so we need to figure out how much we're going to move our window on the X and Y axis. So let's say X equals screen width divided by 2 minus window width divided by 2, and we're going to cast all of this to an int. So add an int cast around this. Let's copy this, do the same thing for y, except this will be screen height and window height. Okay, let's set the geometry for the window. Window, geometry. I'm going to use a string format method. So let's say these will be placeholders for our values. So we have window width for the first value, window height, X, and Y. So this should be near the middle. Cool. We're going to create a string var variable to hold the font name. font name equals string var, and pass in your window. And you can set this too. What do you want your default font to be? So let's say font name dot set, and then pick a font. I'll use Arial, I think. Let's create a font size string var as well. We're going to add this to the window. And we can set a default size. Perhaps 25. Okay, let's create a text area. Text area equals text. We're adding this to the window. I'm going to set a font equal to font name dot get. The name of the font that we want to use will be the font that we set within our font name string var. So now we'll use a size of font size dot get. Font size dot get. Okay, now we need a scroll bar. Scroll bar equals scroll bar. We're adding this to our text area, so pass that in. And I'm going to configure my window using grid row configure. This will allow our text area to expand, but we're going to set a weight equal to 1 so that it does in fact expand. And then we need column configure. Okay. And text area dot grid. I'm going to use the sticky keyword, and this will stick north plus east plus south plus west. So my text area should take most of the window. This is some sample text. Hooray! So it goes down to the next line once it runs out of room on one line, unless you resize the window, which is exactly what we wanted. Let's create a scroll bar. Well, we already created it, we just have to add a few details to it. So that will be near the bottom. And why don't we say scroll bar dot pack side equals right, fill equals y. And then we just have to configure our text area with the scroll bar. So text area dot config y scroll command equals scroll bar dot set. So that should work, but let's test it to be sure. Okay, I'm just going to type a bunch of F's. Okay, look at that. Our scroll bar works. Cool. Okay, let's head to this portion, and we'll create a bunch of buttons. Well, a button, an option menu, and a spin box for the font color, the size, and the font style. So I'm going to place all of these different widgets within a frame. Frame equals frame, add it to the window, and then I'm going to use frame.grid. Okay, let's create a color button to change the font color. Color button equals button. I'll add my button to my frame. I'll set the text of the button equal to color. And I will associate a command of change color, which we have already defined at the top. Where is it? At the top here. Change color. And then, actually that's it for this portion. So then we need to add this button, color button dot grid. I'll set the row equal to 0 and the column equal to 0. So let's be sure that this appears. Make sure you spell grid right. Okay. And we have a color button, but this button doesn't do anything. So let's head to the change color function. Within the change color function, we're going to say color equals color chooser dot ask color, and you can set a title too. Pick a color or else. You don't technically need a title. And then text area dot config. Oh, I should probably print this color, so let me do that. I'm just going to explain something here. So this color is going to be, I believe, a tuple. So let's print it. So let's say that I would like white. Okay, so we have a tuple. We just need one of these values, not both of them. So I'm going to say text area dot config foreground equals our color, but we do not want to assign a tuple to our color. We just need one of these values. So let's say I would like this hex value. So I'm going to say at index 1. And let's try it. Color. Perhaps I would like my text pink for some reason, so we're going with pink. This is some text, I suppose. And we can change this back to by using this color button. Now I would like blue. And we have blue text. Okay, so that is the change color function. I'm going to minimize this because we do not need it anymore. Okay, we're going to change the font next. So head to the portion of our code right after the color button, and we'll create an option menu to list all of the different fonts available to us. So let's say font box equals option menu. We're adding this to our frame. We need to set a variable, a string var, so that will be our font name that we declared up here. Now here's a trick to add all of the fonts as options to our option menu. We can use the unpacking operator, which is an asterisk, followed by font.families, and then call this function. So this will return all of the different fonts available to us, and we just need to set a command. And when we use our option menu, we'll call change font. And we need to add our font box to our grid. Row equals 0, and column equals 1. So this should be on the right-hand side of our color button. Yeah, it's going to look something like that, and you can see the default is Arial that we set. And we can change it to something else, like Comic Sans, or whatever. However, it's not going to change it quite yet, so that'll be the change font function. Before we fill in the change font function, there's another widget that's going to share the same command of change font, so we should create that next. So our next widget is a spin box, which I will name sizebox. This will be in charge of increasing or decreasing the font. So sizebox equals spinbox. We're adding the spinbox to our frame, and we'll set a range. So from underscore, you have to add that underscore, it's kind of weird. This is the range of our spinbox for the font size, from 1 to, let's say, 100. The text variable will be font size. And our command equals change font. So when we use our spinbox and call this command of change font, it's going to pass in our font size as an argument, whereas with option menu, it doesn't pass any arguments. That's why with our change font function, we're accepting a varying amount of arguments, because one's going to pass in an argument and the other isn't. And we just need to add our spinbox. So that would be size box dot grid, row equals 0, and column equals 2. So we should have a spinbox right on the bottom, and it's set to 25. That was our default for our font size string var, which we set as the text variable. Okay, so we can fill in this function of change font now, which will apply both to our option menu and our spinbox. So that is all the way at the top. Within the change font function, we're going to take our text area dot config, set the font equal to font name dot get, and the size will be size box dot get. And that's it for this function. I'll minimize it for now. And let's test it. This is some sample text. Hey, how you doing? Good looking. Okay, so let's change the font. Let's pick Comic Sans or whatever you want, and we can increase or decrease the size, and we can change the color. How about red this time? All right, nice. Now let's add a menu bar at the top so we can save this file or open a file or create a new file and some other stuff. On second thought, I'm going to move these two last lines of code to this section here where we create our scroll bar just so that it's more organized. Okay, so at the bottom, let's create various drop-down menus. So we'll need a menu bar to begin with. So let's say menu bar equals menu. We're adding this to our window. Make sure that's capital, by the way. And window dot config menu equals menu bar. So we'll create a file menu, edit menu, and a help menu. So let's begin with the file menu to add to the menu bar. File menu equals menu. We're adding this to our menu bar and set a tear off equal to 0. We'll need a cascade for it to actually be a drop-down menu. So that will be menu bar dot add cascade. Label equals file, comma, menu equals file menu. Let's see if anything appears yet. Yep, so we have a file menu, but there's nothing to drop down yet. So we need some options. Well, commands technically. File, menu, dot add, command, label equals new, and the command will equal our new file function. Actually, I'll put these together. Okay, so let's copy this and paste it. We have open. The command will be open file. We have save. The command will be save file. And I'll add a separator. File, menu, dot add separator. And lastly, we will have exit, command, quit. Okay, let me show you what this looks like. So here's our drop-down menu. That separator is this bold line going across. So if I was to remove this, then we wouldn't have that bold line. You can keep it in or get rid of it. Do whatever you want. And this is the tear off, so I'm going to remove the tear off. And you get this like tear off line at the top. I guess it's the default. I usually don't like it, so I set tear off equal to 0. So that is our file menu. Let's work on a edit menu. Edit menu equals menu, menu bar. Make sure that's capital too. Tear off equals 0. We'll need a cascade. Menu bar dot add cascade. Label equals edit menu equals edit menu. Edit menu dot add command label equals cut to cut some text. Command equals copy. Actually, that's cut. My bad. Okay, next is copy. So let's copy this and paste it. Cut, copy. We have paste. Command, paste. All right, let's take a look. Oh, make sure you spell label right. Okay, there we go. Okay, so we can cut, copy, and paste. And lastly, we should have a help menu. Help menu equals menu bar tear off equals 0. I think I'll copy this for my cascade. So menu bar dot add cascade help menu equals help menu. What we'll be doing for a command is that we'll be creating an about section that will bring up a pop-up window if you need to display any like help information or anything. So let's say about, and the command will be about. Okay, let's take a look. So we have help, and we'll have an about section that will tell you more about this program. But we need to work on some of these functions. Let's head to the quit function. This one's fairly easy. This is found within the file menu. Window.destroy. That will close out of the window. So go to File, then Exit to exit the program. We don't need it anymore, so let's minimize this. Okay, let's go to the About function. Let's bring up a message box. Show info. This first argument is the title. So let's say about this program. And the text will be whatever you want to tell the user about this program. This is a program written by you. Okay, so we should have a pop-up window when you go to help, then about. About this program, this is a program written by you. The next function is the paste function, so we can paste some text. Text area dot event generate, and the event is going to be within quotes and double angle brackets paste. Let's copy this and change paste to copy, and then cut. Okay, so we should be able to cut, copy, and paste. Hey, how's it hanging? Okay, let's highlight this. Edit, copy. Let's move down to the next line and paste. And we should be able to cut as well. Edit, cut. Nice. Head to the new file function, and we'll set the title of our window to maybe untitled until we save something. So untitled. And I need to delete any text within our text area. Text area dot delete, and we need to set a range. So this has to be a floating point number, the first character until the end. Let's try it. So I'll write some sample text. And we are going to go to File, New. That changed the title, and it deleted our text. So that is the new file function. Let's work on open file. We are now within the open file function, and we'll say file equals ask open file name. So we have a default extension, if you would like one. Default, I think I spelled that wrong. Extension equals, let's say, a txt file, comma, what are the accepted file types? I'll set this equal to all files, comma, and then we need asterisk dot asterisk for all file types, as well as text documents. So these are what is accepted when we look for a file. So we have either all files or all text documents. Text documents, comma, asterisk dot txt. Okay, so then let's try some code. We'll set our window title equal to os.path.base name of our file, so that we will change the title of the window to match whatever the file is that we opened. Then let's take our text area, delete what's currently here, from 1 until the end. Take our file, use the open function, open our file, and read it, so pass in our text area dot insert beginning at index of 1.0 file dot read. Then you can catch any exceptions too. I'll just write except exception, but it's better to name specific exceptions. I'll just print couldn't read file. And we should close our file at the end within a finally block. Finally, file dot close. We'll need a sample file to read, so I'm going to create a new file on my desktop. I'll call this test.txt. And let's write something. Whoa, you can actually read this? Awesome. Okay, let's save, close out of it, and run our program. File, open, test.txt, open. Whoa, you can actually read this? Awesome. Nice, so we know that the open function is working. If we need to create a new file, just go to File, New, and that will delete our old text. So lastly, we have Save File. Underneath the Save File function, File equals File dialog dot ask save as file name. So this will be the default name for the file, but you can change that. Initial file equals, let's say, untitled.txt. You can set a default extension. Default extension equals, let's say, txt. File types equals all files, comma, then asterisk dot asterisk for all file types, and any text documents. Text documents asterisk dot txt. Okay. If file is none, that's if they close out of our file dialog, we'll just return. Else, So we'll set the window title first. Window title os.path.base name file equals open our file and write file dot write, take our text area and get the text from index 1 through the end. Catch any exceptions. It's better to name them instead of just doing a general accept exception. But I'm just going to print couldn't save file. And finally, close our file.close. All right, so let's test it. So I'm going to change the font. I wonder if impact is in here. Yes, it is. I'll change the font size, maybe 30, and I'll pick a color. How about this swamp green color? Okay, so write something, perhaps some lyrics to a song you like. I should probably test copying and pasting. Edit, copy. Edit, paste. Nice. All right, let's actually try and save this now. I'll go to File, Save. The default file name is Untitled because we set it to that. I'll say All Star Lyrics. And save. Now I should be able to open this. So I'm going to go to my desktop. Here's that text file. I'm going to open it, and here are the lyrics that I wrote within my text editor. And let's try and read this. So let's go to File, Open, find your text document, Open, and would you look at that, my lyrics are still here. However, this program doesn't save the font. So I thought of a fun last-minute project that we can do. We can actually use our text editor to write a Python file, much like what we do with PyCharm. So let's write a program using our text editor program. It'll be just a simple program. Let's print hello world and ask for some user input. Let's say name equals input. What's your name? And we will print hello plus our name variable. And you can change the font and everything too if you want. Okay, so let's save this. File, save. I'll save this to my desktop, but make sure you save it as a py file, a Python file. I'll name this as hello.py and save. Now, to run a file using command prompt, we need to find the directory that contains our Python file. Mine is hello.py, and it's located on my desktop. So I need the location, right-click, go to Properties. You can copy the location. Then within command prompt or terminal, you can change directory by typing cd space and then paste your new directory, the new location. Enter. Then to run a Python program, type Python space and then the name of the program, the Python file. Mine is hello.py. Hit enter. Hello world, what is your name? Bro. Hello, bro. I just thought that would be a fun last-minute project that we can do. You don't even technically need an IDE to write a Python program. Screw you, PyCharm. Well, everyone, that is a basic text editor program. I will post the code for this program in the comments section down below. And, well, yeah, that's a basic text editor program using Python. Alright, ladies and gentlemen, let's create a game of tic-tac-toe. To begin, we'll need to import tkinter as well as random. And let's begin by defining all of the different functions that we'll need. let's define a function named next turn. For the time being, we'll just write pass. We'll fill this in later on. We'll need a function named check winner, a function named empty spaces to check if there are any empty spaces left, and lastly, a function named new game that will launch a new game for us. Okay, we have our 4 functions. Now let's create a window. Let's create a window. Window equals tk, and at the end of our program, we need to use window.main loop. And when we run this, we should have just a small basic window. Let's set the title. Window.title. Let's set this to tic-tac-toe. We'll need a list of players. Players equals x, comma, o. And with the way that we're writing this program, we can swap these symbols with a different character. For example, we could say $sign is playing against the @ symbol too, but I'll demonstrate that later. Let's keep it as X and O for now. Now we need to select a random player to begin. Player equals random dot choice and pass in our list of players. Now we'll need 9 buttons. I'm going to create a 2D list of buttons named buttons. And this will be the first row. This will be the second row. For the time being, I'm just going to initialize these with 0 for everything. And put these all within a list. So we have a 2D list named buttons. And to better visualize this, I'm going to place each row on a new line. So that's what our board is going to look like. We have a 2D list named buttons. We'll need a label to display whose turn it is. Label equals label. I'll set the text equal to player plus the word turn. And I'll set the font to font equals, pick whatever font that you want. And I am going to pack this label, label.pack, and set the side equal to top. And let's run this just to test it. Okay, looks like it's X's turn. Let's try it again. O's turn. Okay, that's fine for now. Let's create a reset button. Reset underscore button equals button. I'll set the text equal to restart. It's going to be a restart button or reset button. Pick a font. Maybe I'll set the size to 20. And we'll need a command. Command equals new game. When we click on this button, it's going to call this new game function for us. And we need to pack this button. Reset button dot pack, and I will set the side equal to top. Okay, let's see if that appears. All right, so we have our turn order, a label that will display whose turn it is, as well as our reset button. Now we'll need to create all of the buttons to add to our 2D list named buttons, but I'm going to place these all within a frame. Frame equals frame. We're adding our frame to our window, and I'm going to pack this frame. Frame.pack. Now we'll take our 2D list of buttons and add a button to each spot, and I think the best way to do this would be to use nested for loops. We'll have an outer for loop in charge of the rows. For row in range 3. Remember, we only have 3 rows and 3 columns. The inner for loop will be in charge of the columns. For column in range 3. And inside the inner for loop, we're going to create a new button. We'll say buttons at index, row, and column. We have 2 indexes because we have a 2D list. So buttons at row whatever, column whatever, depending on what iteration we are within our for loops. We'll create a new button, and we'll set the text Oh, first add this to the frame. Almost forgot about that. We're adding our buttons to our frame and adding the frame to the window. Now we'll set the text equal to a blank set of quotes because we don't want any text. We'll set the font. I'll just copy what we have here for label. For a width, let's say 5, and a height, let's say 2. I'm going to hit enter just to move down to the next line because we still have a few more things to fill in. Okay, we'll need a command. Command equals, and I'm going to set this equal to a lambda function, so we need some arguments. Actually, I think I'll pass in some keyword arguments. Row equals row, and column equals column. Then our expression is next turn, and we will pass in row and column. Now we also need to add our buttons to our frame. Buttons at index of row and column. We'll use the grid function for this. Grid row equals row and column equals column. And it's always a good idea to test your program after making any major changes, so we should have our label, our reset button, and our grid of buttons. Now that the main body of our program is complete, let's head to the next turn function. And remember that we're passing in row and column as arguments, so we need to set up those parameters within the next turn function. Row and column. And the first line within here, we would like access to our player. So let's say global player so that we have access to it. And we're first going to check to see if the button that we click on is empty. So buttons at index of row and index of column. To access the text of a button, just add a third index operator and type in text. If the text of our button that we click is equal to a set of quotes, that means it's empty. And when we call check winner, 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 chicken dinner, and it's false, there is no winner, then we will fill in that button with our player's character, whatever it is, X or O or whatever we decide. So within here, let's check to see if player is equal to players at index 0. That is our first player, and remember that we created a list of players, and we're planning on swapping these later. We could say like if player is equal to X, but that would make our program less flexible if we want to pick like a different character instead of an X. So if player is equal to players at index 0, whatever symbol is there, then we are going to take buttons at index of row, index of column, take our text, and set it equal to our player. And we should check to see if there's a winner after filling in this button. If check winner, and we still need to fill in this function, returns false, then we will switch players. Player equals players at index of 1. And label dot config text equals players at index 1 plus the word turn. So what we did here is that we're checking to see if after placing our text of our player on that button that we click, if there is no winner, then we're going to swap players. Player equals our next player, and we're configuring our label so that it displays the next player's turn. Players at index 1, turn. Now what if there is a winner? Let's say else if check winner is true. Then we will take our label dot config and set the text equal to players at index 0 plus the word wins. Now let's add another else if statement. else if there's a tie. Let's say check winner is equal to the word tie, because we are already using false and true. Then let's change our label, and I'm just going to copy this. Text equals the word tie. Okay, so let's create an else block. So that goes right here. So if it's not player 1's turn, player at index 0, then it's our other player's turn, player at index of 1, so O then. So we just need to mostly just copy this text and change a few things around. So I'm going to copy all this. And within here, let's set player equals players at index 0, then players at index 0's turn, players at index 1 wins, and that is it. Now our next turn function is now complete. Let's head down to the check winner function, and we need to check all of the different win conditions and return true if somebody won, false if there is yet no winner, and the word tie if it's a tie. So let's check all of the horizontal win conditions. So we can do this using a for loop. For row in range 3, we need to check the text of each button in each row. If buttons at index of row and column index of 0, we'll use the index operator to check the text, is equal to the next button in our row. So I will copy this and change 0 to 1. Check to see if that is equal to buttons at index of row, index of 2. And I'm going to check to see if this is all not equal, let me move this a little bit, to a space. So if that is the case, that means somebody won. So if all of these buttons are the same and they are not equal to an empty space, that means they're all the same. So let's return true. That means that somebody won. Now we need to check the vertical win conditions if anybody has the same character all the way down a single column. This next for loop is going to be for column in range 3. For the first button, this will be button at index of 0 and column, then 1 and column, let me just paste that, and 2 and column. Now we need to check the diagonal win conditions. So if buttons at index 0, 0, that's the top left corner, if the text of that button is equal to buttons at indexes of 1, 1, is equal to the indexes of button 2, 2. And if all of this does not equal an empty space, then return true, so there is a winner. And we have one last win condition to check, that is the other diagonal win condition. So we just need to change some of these indexes around. So we have 0, 2, 1, 1, and 2, 0. I'm going to change this statement to an else if statement. Now we need to check to see if there's any spaces remaining. Else if we will call the empty spaces function, which we have yet to fill in. If this returns false, then we will return the word tie. And lastly, else. Else there is no winner and no tie, so we will return false. And that is it for the check winner function. Let's test this. So this doesn't account for a tie quite yet, but we can fill in some of these spaces. Looks like X wins, and we can no longer fill in buttons. And we cannot start a new game quite yet either. Within the empty spaces function, let's create a local variable named spaces and set this equal to 9 whenever we call this function. For row in range 3, and we'll create a nested for loop for column in range 3, we will check the text of each button if buttons at indexes of row and column, and we will check the text to see if it's not equal to an empty space. If that is the case, spaces minus equals 1. Then we'll write an if statement. If spaces, as in spaces remaining, is equal to 0, that means we will return false and there are no spaces left. Else, we will return true. Okay, let's test it. So this time I'm trying to get a tie. Yep, it looks like it's a tie. This next part's optional, but I would like to change the color of each button for the winning combination. So within our check winner function, underneath the first win condition, I'm going to take buttons at index of row and index of 0, use the config method, and set the background color equal to, let's say, green. And I'm going to repeat this process for the other buttons within this win condition. So that is row 0, row 1, and row 2. I'll copy all of this, paste it, and switch some of these around. So these should all be matching. So 0 end column, 1 end column, and 2 end column. Okay, so we have 0, 0, 1, 1, and 2, 2. And one more. 0, 2, 1, 1, and 2, 0. Now, when we have a winning combination, the color of the buttons involved in that combination are going to change to green. Now, if there's a tie, let's change all of the buttons to, let's say, yellow. So I'm going to write nested for loops for this. For row in range 3, for column in range 3, take our buttons at row and column and change the background color to yellow or some other color of your choosing. So if there's a tie, they should all be yellow. I'm trying not to win here. It's actually more complex than what I thought. Yep, it looks like it's all a tie. And the last thing that we need to do is to fill in the new game function so that we can begin a new game. So let's say global player, we would like access to our player from inside this function and set player equal to a new random choice. Random.choice and pass in our list of players. And we will change our label.config and set the text equal to player plus the word turn. And we also need to reset all of our buttons. For row in range 3, for column in range 3, buttons at index of row and index of column dot config text equals a set of quotes, so it's empty, and we'll change the background color back to what was previously. So the default color for buttons is actually hexadecimal, F0, F0, F0. So this function will begin a new game for us, and let's test it to be sure. I'm gonna start a new game, reset. I'll actually try and win this time. And reset. Okay, so it looks like the new game function is working. Now, another thing that you can do too is that you can change the players around Let's say we would like to play as $sign and @sign. So this program is flexible enough so that you can change the icons of the players. Alright everybody, so that's a basic game of tic-tac-toe for Python. If you would like a copy of this code, I will post all of this to the comment section down below. But yeah, that's how to code a basic game of tic-tac-toe for Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video we're going to create a game of Snake using Python, so sit back, relax, and enjoy the show. First thing we should do is import from tkinter as well as the random module. And let's define all of the different classes and functions that we'll need. So let's create a class for our snake object as well as our food object. So for the time being, I'm just going to write pass for my classes. We'll fill these in later. So we have class snake and class food. And let's define all of the different functions that we'll need. So let's say we have a function named next turn, change direction, check collisions, and lastly, game over. Okay, for change direction, I'm going to have one parameter, a new direction. Now, when I create a game, I like to place a bunch of constants at the top of my game. Constants are variables that you do not want to change later. They're kind of like the settings. However, in Python, there are no constants compared to other programming languages, so we're just going to create a bunch of variables that will behave like them. So, constants are values we do not want to change, and they're kind of like the game settings. And I place them at the top for convenience. And the naming convention for a constant is that all the letters are uppercase. So these will be settings like the game width, the speed, etc. So let's say the width of our game will be 700, but feel free to take the liberty to pick whatever size you want. So we have game width, game height. I'll set this to 700 as well, so it's a square. Let's say we have a speed, the speed of the snake. How often will our canvas update? So let's say 50, but the lower the number, the faster the game. And a space size. How large are the items in our game, like the food and body parts of the snake? So I'm going to pick 50, but you can change this. And body parts. How many body parts does our snake have when we begin a game? Let's say 3. How about a snake color? You can pick a color name, you can use RGB values, or you can use a hexadecimal value. So I'm going to pick green. 00FF00, but you can pick any color you want. How about food color? Equals red. And that is FF0000. And what about a background color for the canvas? Background color. I'll pick black, so that is 6 zeros. Feel free to mess with some of these colors too. So we have a green snake, our food is going to be red, and our background is going to be black. So that is all of the constants for our game, but you can feel free to adjust them if you like. Let's head down to the bottom and make our window. So we have window equals tk, and at the very end we should have window.main loop. Let's set a title for this window. Window.title. Snake game. Okay, fine, I'll spell it right. Snake game. And if you do not want your window to be resizable, you can use resizable, and then you have to pass in false twice. It's kind of strange, but it's how it is. Okay, we should have a small window, and we cannot resize this even if we tried. Okay, let's create a score label. Well, we probably need a score first. So let's say score equals 0 and an initial direction. Direction equals, let's say, down. Now let's create a score label. So let's say label equals label. We're adding our label to our window. Let's set the text equal to score. colon. Then I'm going to use the format method, and we will pass in our score, whatever it is. And I'll set a font, pick whatever font you prefer. And 40 is a decent size. And then I am going to pack this label. Let's test it. Okay, we're getting somewhere. We'll need to create a canvas. Canvas equals canvas. We're adding it to our window. I'm going to set the background color equal to our background constant. I'm going to set our height equal to the game height and the width equal to the game width that we set. And we need to pack this. Canvas.pack. And we should have a game board. I'm going to try and center this window when it appears, so we can do that using a few lines of code. The first thing we'll do is update our window so that it renders. And then we need to find some dimensions. So let's say the window width equals window.w info width. And window height equals window.w info height. We'll need our screen width equals window dot screen width, and screen height equals window dot w info screen height. Where is it? There it is. Okay, then we need to see how much we're going to adjust the position of our window. So let's say x equals screen width divided by 2 minus window width divided by 2. And do the same thing for y. Except this will be screen height and window height. And that will be y. Okay, then we need to set the geometry. Window dot geometry. We're going to use an f string. So let's set the window width times window height. And then add plus x plus y. So when we pass in x and y, these cannot be floats. They have to be whole integers. So let's add a cast around x and y. Okay, now this should be fairly close to the center. Yeah, that's not too bad. Now, when we begin a new game, we should create a snake object as well as a food object. Snake equals snake, and call the snake constructor, and food equals food. Okay, let's fill in our food class first, because I think that'll be easier than our snake class. So let's head to the food class. Now let's create an init method. So def init, this will construct a food object for us, and we need to place our food object randomly. So for the x coordinate, let's say x equals random.rand int, and we need a range. The range is going to be 0, comma. Now, with our game board, I view it like a chessboard. There's a given amount of spaces. So 700 divided by our space size is 14 possible spots on the x-axis, and then 14 possible spots on the y-axis. So I need to pick one of these spots randomly. So let's say game width divided by our space size, so we'll get a random number between 0 and 14. However, this should be exclusive, so let's say -1. And for good measure, I'm just going to add a set of parentheses around this. Okay, and then we'll convert this to pixels. So let's multiply all of this by our space size, the size of each item in the game. And we'll do the same thing for Y, but change game width to height. Okay, we should be good. All right, now let's set the coordinates. Let's say self.coordinates equals a list of X and Y, and that's it. But make sure you spell coordinates right. Now we need to draw our food object on our canvas. Canvas.create oval. You can pick a square too if you like. We need a starting corner. That will be where X and Y is, and an ending corner. So that will be X and Y plus our space size, the size of an object in a game. So X plus space size, Y plus space size. And you can set a fill color too. Fill will be our food color that we declared. And I recommend adding a tag as well. That'll make it easy to delete this object. So tag will equal the string food. Now let's just test this. So we should have a random circle, or a square if you picked a square, appear someplace at some spot on my game board. Cool, seems like it's working. Let's work on the snake class next. Our snake class will need a constructor. And we will set a body size equal to our body parts. We'll need a list of coordinates. We'll fill this in later. And a list of square graphics. So that will be a list. Okay, so we need to create a list of coordinates. We can use a for loop for that. So let's say for I in range 0 through body parts. We will take self.coordinates and append a new list. And the coordinates for each body part at the start of the game will be 0, 0, so that our snake will appear in the top left corner. Now we'll need to create some squares. Okay, so for X, Y in self.coordinates, and remember that we have a list of lists, so that's why we're using XY in self-coordinates. We'll create a square equals canvas.create rectangle. So we need a starting corner that will be X and Y. Then X plus our space size, the size of each object in the game. Let me use the constant though. Space size, Y plus space size. And let's set a fill color equal to our snake color. All right, and let's set a tag for convenience. Tag equals a string of snake. Okay, so we have a list of squares and we can append each square into our list. Self.squares dot append and pass in whatever square that you create. So we have a snake that has a body size, a list of coordinates, and a list of square graphics. Now after testing this, we should have the head of our snake in the top left corner, And now we just need the snake to move in a given direction every turn. So the initial direction is down, but we'll be able to change that later. So let's head to the next turn function. And there's actually two things we'll need as parameters that I forgot to fill in. Snake as well as food. And we will call this function when we begin our game. So let's unpack the head of the snake. So that's x, comma, y equals snake dot coordinates at index of 0. So that's the head of the snake. The coordinates will be stored in x and y. So let's check to see if our direction, our initial direction, equals up. And we'll need some else if statements. We'll fill this in just a moment. Else if our direction equals down, then left, and then right. Okay, if our direction is up, then let's take our y coordinate for the head of our snake minus equals our space size so that we move one space up. And then down is plus equals space size. Left is x minus equals space size. And lastly, right is x plus equals space size. Okay, then we need to call the next turn function again for the next turn. So we can use window dot after. We need a time. So let's say our game speed. We're going to call the next turn function, and we need to pass in our arguments of snake and food. Snake, food. Oh, and make sure you're not actually calling the next turn function inside of the after method. You just have to write the function name of next turn without the parentheses. Okay, so let's update the coordinates for the head of the snake and write that before we move on to the next turn. So snake dot coordinates, and we will insert a new set of coordinates after updating one of them. So 0 will be the index, the head of the snake, and we will insert x and y coordinates at this new location. Now we're going to create a new graphic for the head of the snake. Square equals canvas dot create rectangle, pass in x and y for the starting corner of our rectangle, and the ending corner will be x plus our space size, y plus our space size. And then I will add a fill color of snake color. And then we need to update our snake's list of squares. So that will be snake dot squares, and insert at index 0 a new square that we create. Okay, let's test this. One last thing that we'll need to get this program to run is that after you create your snake and food object, we should call the next turn function and pass in our snake and food object. So we should be able to test this. So our snake is going to move, but we need to delete the last body part in our snake within the next turn function. But before we update to the next turn, let's delete the last body part of our snake. So delete snake dot coordinates at negative index of 1. That is the last set of coordinates. We will update our canvas. Canvas dot delete snake dot squares an index of negative 1. And lastly, delete snake the list of squares at index of negative 1. So it should appear that our snake is moving. Cool. We need some controls for our snake. So at the bottom of our program, let's bind some keys. Let's do that here. So window, dot bind. Let's bind the left arrow key. And we will use a lambda. The argument is event. And we will call the change direction function and pass in the word left. Okay, then we have to do the same thing for the other directions. So we have right, pass in right, up, pass in up, down, pass in down. Let's head to the change direction function. We need to access our direction, global direction. This is the old direction. If our new direction that is passed in is equal to left, and if our old direction, just direction, does not equal right, because we do not want to go backwards and do a 180-degree turn, then we will set our direction equal to our new direction. And we just need to repeat this for the other directions for new direction. And I'm going to change this to else if. Else if new direction is right, and our direction is not already left, then we have up. If our direction is not down, and down. If our direction is not up. Okay, so we should be able to change the direction of our snake. Sweet. Okay, we need to eat that pesky apple next, so let's work on that. There's nothing else that we need to change within the change direction function, so I'm going to minimize this function and head to the next turn function. We'll place an if statement here. If x, remember that we unpacked the coordinates for the head of the snake. If x, the x coordinate for the head of the snake, is equal to our food object's coordinates at index of 0. That's the x coordinate for our food object. And y is equal to food coordinates at index of 1. That means they're overlapping. Let's take our score and increment it by 1. And change our label, label.config. The text will equal score, and then I'm going to use the format method and pass in my new score. Let's delete our food object, and we gave our food object a tag, so we can just use the name of the tag to delete it and create a new food object. Then I'm going to write this part of our program within an else statement. We will only delete the last body part of our snake if we did not eat a food object. Okay, let's test it again. So I have 3 body parts. Now I have 4, 5, 6, 7, 8, 9, 10. You can see that the score is going up too. Okay, let's work on collisions next. because I should not be able to go off screen like this. There's one thing that we're going to change. So let's add an if statement that will check collisions. This will return true or false if we detect a collision, and pass in our snake object. If there is a collision, we'll call the game over function. Else, we will update to the next turn. Okay, let's fill in the check collisions function, and we no longer need our function of next turn. Actually, we don't need these classes either, so I'll minimize them. Okay, check collisions. So it looks like we will need a parameter of snake, so be sure to set that. Let's unpack the head of the snake. X, Y equals snake dot coordinates at index of 0. And let's check to see if we cross the left or right border of the game. If x is less than 0, or x is greater than or equal to our game width, then return true. I think for testing purposes, I'm going to print something to the console window. Game over. Let's test it. Okay, I'm going to go over to the right border, game over, and our game stopped. Let's go over the left. Game over. Cool, so we know that it's working. Okay, let's do the same thing for Y. We can use else if here. If Y is less than 0, or Y is greater than or equal to our game height, let's print game over and return true. And we should probably test it. Okay, I'm going up, game over, and let's go down. Game over. So what if our snake touches its tail or another body part? So let's say for I, actually I isn't too descriptive. Let's say for every body part in snake dot coordinates. So we're going to set this to everything after the head of the snake. We're going to check to see if any of the coordinates are matching. If x is equal to body part at index 0, and y is equal to body part at index 1, then return true. And I'll print game over to test it. Print game over. Otherwise, we can return false. There are no collisions. I think I'm going to change the size of the snake to 10. Okay, let's run into each other. Cool. Game over. And the last thing that we need to do is to fill in the game over function, because it looks like everything else is fine. So head to the game over function, take your canvas, and delete all. And we'll create some game over text. Canvas, create, text. I would like this in the center of my canvas. I'll take canvas w info width divided by 2, comma, canvas w info height divided by 2. I'm going to put some of this on the next line for readability. I'll set a font. Pick whatever font that you want. We'll need some text. Text equals game over. Pick a color. Red's decent. I'll add a tag too, for convenience. Game over. And that should be it for the game over function. I'm going to change the body parts of the snake back to what it was originally. And we should probably test that game over screen. Alright, it appeared. Okay, so let's change some of these settings around. You can create a larger game board, let's say 1000 by 700. That still works. You can slow down the speed or speed it up. So 100 will be about half as fast. It's going pretty slow now. But what if we set it to 20? You can change the space size. So everything is a lot smaller now, including the food object. You can change the body parts. What about 20 to begin with? That's fairly excessive. I'll change that back to 3. You can change the snake color. Let's say we would like a blue snake. So that is for a hex color. 4 zeros and then 2 Fs. You can change the food color. So let's say we would like a yellow food object. So that would be 4 Fs and then 2 zeros. Kind of resembles the Python logo, that color scheme. You can change the background color too. So let's say all white, that would be 6 Fs. I do not like that. Go back. Delete, delete, delete. Alright, well, that should be everything. Let's run this game one last time. Well, everybody, that is a very basic game of Snake for beginners. I will post all of this code to the comment section down below. But yeah, that's a basic game of Snake using Python. Hey you. Yeah, I'm talking to you. If you learned something new, then help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.